Okay. Okay. So this session is called "Let's Write a Schema Together." But before that, I thought that maybe it was interesting to have an overview of what is a schema, entity schema, and entity schemas are related with checks and also with RDF. So let's do a very short introduction to RDF and checks, and then the tools that I know about writing entity schemas, and let's see if we have time to do the exercise of creating an entity schema, and then if we have time, some applications and some discussion. So let's see how we do it. So RDF, probably, I think probably you know it, RDF has been with us a lot of time. It's a recommendation, and it has a graph structure. For example, this example, which is the example that I will follow in the rest, is about Tim Berners-Lee, that the type is a human, the birthplace is London, the city, this is London is a city, it's a metropolis. He has a label, Tim Berners-Lee, and a birth date, and so on and so on. So this is the structure of RDF graphs. And RDF has been, as I said, with us since 1998. So there is a whole ecosystem of tools around RDF. So there is the different syntaxes, for example, Turtle or JSON-LD. There are also, which is interesting, different vocabularies that you can, so the nice thing of RDF is that you have these vocabularies. And also, so this is an example of this graph represented in Turtle. And also in this ecosystem, you also have a Sparkle, which is also interesting because in Wikidata, we have the query service, the language that is used is Sparkle. So in this example here, for example, if we want to select a person from here, the person, the birth date, then this would run and we obtain this result. So this is about RDF. So this is the RDF is a language to represent graphs, and that allows us to represent graphs and with these properties which are URIs. And then we have Wikibase or Wikidata. Probably in this, I don't have to introduce it here. But something which is interesting about Wikidata, and it's interesting that at least you know that it is different. The Wikidata data model is a bit different from RDF, so they are not the same. So, for example, in the graphs that we represent for Tim Berners-Lee, this is the sample here is Q80, has the birth date is 1955, the birthplace was London, the country UK, it is an instance of, this is P31 human, and so on. But then the things that are start to be different is that the links between these nodes in the graph can be qualified. So we have references, we have qualifiers. So for example, we can say that Tim Berners-Lee, the employer was the CERN, starting in 1980 and ending in 1980. So this is an example of qualifier. And then he was employed twice. So also it's starting in 1984 and ending in 1994. So we have links that can be qualified with these different nodes. But also, which is interesting, is that we can say, okay, he was awarded, the point in time was in 2013. This is PA, is the Princess of Asturias Award. It is in my region in Asturias. We awarded him a prize. But which is interesting is that we can also say, okay, he was awarded in 2002 together with, and this is a link to another node in the graph, which is an interesting thing that, I mean, this kind of graphs are not as simple as they look at the beginning, because we have the possibility that the nodes, the values of the qualifiers are nodes in this graph. Okay, so this is something which is a bit interesting. But anyway, this is the data model of Wikidata. If you are attending these days, probably you already know what is Wikidata, and I call it Wikibase because it is not only Wikidata, we have also other instances of this data model, which I call it Wikibase graphs. And what is the relationship between Wikibase and RDF? The relation is that the Wikibase and the Wikidata provides RDF serializations of the different items, so we can access those RDF serializations through the query service, also through the dumps, which is also interesting, and it is possible to download the dump of Wikidata. Is huge, but we can download it, and then we can process that RDF serialization of the Wikidata. And I say this because also we can do the Sparkle queries, and also because the entity schemas, what are representing is not directly the data model of Wikidata, they are representing the serialization of this data model in RDF. So it's, and I think this is important to take into account if we want to model data using entity schemas. So in this case, this is just an example of a Sparkle query for Wiki that obtains values from Tim Berners-Lee. And this serialization of Wikidata into RDF, this is for this example of Tim Berners-Lee, the Princess of Asturias, and this has these qualifiers. This is represented in this way. I mean, I put here the numbers. So this is the way that it is represented in RDF. So we say Q80 has this P166 is the award received. And then we can qualify it saying, okay, P585, 2002, and so on. So this is how we represent qualifiers in RDF. And I say this because it's important if we want later to represent data in shape expressions, because what we are going to represent in shape expressions is this serialization. It's not directly this data model. So, and that's something, part of the complexity of writing shape expressions, I think, comes from that, because if you think that you are only interested in these direct links, you may think that it is easier, the problem, but when you want to also model the qualifiers, then you have to take into account this serialization, which is maybe it's not obvious. So I think from a mental point of view, it's interesting to simplify this. For example, we could represent this information could be simplified. This is this doesn't exist, but it could exist, which is a syntax saying, okay, Q80 has the statement P166 with this value, which is the Princess of Asturias, and then with these qualifiers. 585 is a point in time, and together with these values from the node. Okay, so this is how we could represent. And I also say this because later I will talk about a language that I propose called WSEX that maybe is useful because it could model this directly. Okay. Okay, so RDF, just going back to RDF, RDF is very nice. It's like the basis of semantic web, and it is, and a lot of the things that I say here about RDF can also be said about Wikidata. So Wikidata is also has a lot of good things. We are in this session probably because we know that it has a lot of things. But on the other side, there are some problems when we want to do queries, consuming data from Wikidata. Maybe it's not as nice as it could be. Also, the data, maybe the quality is not as nice as it could be. Why? Because sometimes we don't know where to start. We want to do some Sparkle queries. We don't know what is the structure of the different items, and we would like to know what is the description of the items. And for that, in the world of RDF, we with Ripple and other people, we created this language called shape expressions, which are all these shapes. And the idea of these shapes is to describe the contents of RDF. And this is the idea, the same idea that was used for EntitySchemas, to describe the contents of Wikidata items. So the goal here is that the producers will understand better the contents, so that when we see an entity schema, we could understand what is the structure of that item. The consumers could verify that item before processing it, so it could verify that it follows the structure, and then we don't have to do this, what we call defensive programming. Okay, we don't have to check if there is a value which is an integer, because we already know that it is an integer, or these kind of things. In other languages or other technologies, there are other tools, for example, XML schema for XML and so on, but I will skip this part. And these schemas for RDF they allow us to jump from implicit schemas, which are the schemas that we know that they exist. Can you hear me now? Hello?
Yes. Yes.
Okay. Yes, I was muted. Okay. So, so the idea, for example, of talking about implicit schemas is that, for example, when we are modeling data in Wikidata, we have, imagine we are talking about Tim Berners-Lee. So there is an implicit structure. So there is an implicit structure which we know it is a human, and the humans have a birth date, and for example, they don't have ISBN code, for example. So there is an implicit schema, even if we don't. I mean, probably one feature which is very nice of Wikidata is that it doesn't impose a schema on all the items. You can edit it in a free way, but on the other hand, sometimes we know that there is an implicit schema. So that's why we wanted to talk about these schemas, and that's the main goal of EntitySchemas, is to have a language that allows both the producers and the consumers to understand what are the items that they are talking about. And now this is an example of a shape in RDF. So a shape describes what we are describing in a shape is the topology of a node and the neighborhood of that node. For example, if we are talking here about Tim Berners-Lee, we say, okay, it has a birthplace, which is a city, a label, which is a string, the birth date is a date, an employer, which is an organization. And this is the idea of a shape, that we are describing this neighborhood. So, for example, we have this node here, and we can represent that this is the sex, the entity schema of this node. But I mean, I'm talking about entity schema or sex is more or less the same. They are different, but this is the language. Okay, so for example, a researcher has a label which is a string, a birthplace which is has the shape of a place, a birthday which is a date, an employer which is an organization, and so on, so on. Okay. There is if you click in these slides, you could see the link to the tool and so on. So the evolution of the language is something like this. Now we started in 2013, so 10 years ago, more or less. And now we are working in a IEEE standard for sex. So this is something that we are currently standardizing this language. Last year we added extents, inheritance. I will put an example later of what is extents. And this is the evolution. So this is a language that is, it started here, but now we are in this process of standardizing the language. Some people may wonder what is the difference between sex and shackle, or what is the role here, because I mean, if you are in this world, maybe you know that there is, in the last session, they were mentioning shackle, and they say, okay, in Wikidata they wanted to use sex. For me, this picture defines more or less the idea of the main difference between the mindset of sex and entity schema, sorry, shackle. In sex, we are describing, so sex are mainly descriptions of the items. So you say what is something about, what data we want to have. For example, we want to say we have a birth date with these properties, and we can also validate the items. So we move here in between description and validation. And a difference here is that in shackle is more about constraints. So shackle is more about saying what something has to obey, what is the integrity constraints that we want to enforce, or to what data we don't want to have. So this is the mindset of shackle is a bit different. It's more trying to restrict the things that we don't want to have in the items and so on. So there are more constraints. And probably this is also the difference why in Wikidata you also have property constraints, which could be more here. They are more here about constraining data, and entity schemas, which are more here. They are describing the data. So this is I put like these icons here. So one thing is information, description. Another thing is validation, which is also interesting. Another thing is restrictions, constraints. Okay, so this is the different things. And now my plan was to do a short introduction to sex. I don't know if you want. I think is interesting. Of course, you can interrupt me when you want, so the idea is to do it. So please do it, and let's go. So any interruption, any question until now? No. Okay, let's continue. So the short intro to sex is, I mean, the idea of sex. Maybe you don't disagree, but we tried when we were defining the language that it should be human readable, also concise, and also machine processable. I mean, it's a language that there is a validator, a tool that can check that the items conform. It's not natural language. This is a machine language. It's like a programming language, but the goal is that it is also human readable. I mean, in my opinion, the complexity of the language is very similar to Sparkle. So if people in the audience, they know how to do queries in Sparkle, in the Wikidata query service, probably you will not have any problem to do to create an entity schemas. Maybe the main problem at this moment probably is that the tools for entity schemas are not as mature as the tools for Sparkle. That's my opinion. There is also two syntaxes. There is a compact syntax for humans and RDF or JSON-LD for machines. And there is this is the official, if you want to have more information, this is the official place. There is a lot of tools and implementations. So this is a link. And I have, I mean, I would say probably the best one is this one in JavaScript. This is the probably, we don't use the term reference implementation, but probably this is the reference one. I had implemented this one in Scala, but I have to say that since last summer, I changed my programming language, my favorite programming language, to Rust. So I started to do this implementation in Rust. This is still work in progress, but it is more or less usable right now. But as I said, it's work in progress. And I will be very happy if anyone in the audience also wants to practice Rust and help me with the implementation. So this is something that I implemented right now. There is also some online demos. If you want to practice with Sex, there is also all these online demos. This is Sex Simple which is based on the JavaScript implementation. The RDF shape is based on the Scala implementation. My plan is to replace this by the Rust implementation and so on. And the language, as we said, is very similar to Sparkle. The syntax is inspired by Sparkle. We have the first part is the prefix declarations. For example, this is something that the difference between the Wikidata query service and the Wikidata query service, it is not mandatory to add the prefix declarations, but in the entity schemas, at this moment, it is mandatory, because if you don't add the prefix declarations, the validator will complain. So this is something that probably could be improved. I mean, probably something I am happy, because in the last session, I saw that the Wikidata, you are working to improve these tools, and probably, for example, having the possibility not to require to do the prefix declarations and to infer the default ones would be very useful for the users. And the idea is, for example, here we are defining a researcher has a label, which is a string, and knows other researchers. So this is the idea. So you can see that we will have, this is a cyclic data model. So you are saying that researchers know other researchers, and we don't have any problem with that, because the language supports this kind of cyclic data models. And then I have here an example, just to play a little bit. So for example, we have Alice has a label, which is a string, and knows herself. So the validator would say, okay, she is okay. Bob is a researcher. Let me check it. Bob has a label and knows Alice, should validate. But notice, for example, that a validator that is trying to validate Bob, as Bob knows Alice, the validator should start in a loop saying, okay, if she knows other researchers, I have to validate that the other people that Bob knows, they are also researchers. So you have this kind of cyclic structure, which makes the validators more complex than just if they are just checking the neighborhood. So okay, you have to go to an item, validate the neighborhood, but once you go to those neighbors, maybe you need to validate those neighbors. So that's why the validators, in the worst case, they could need to validate the whole Wikidata, which could be very expensive. So sometimes it's also important to take into account that the validators could be expensive. They are not just very fast. Okay, depending on which entity schemas you define. Okay, and then you have, for example, Carol as researcher. In this case, Carol has two labels. So in this case, it would fail. So this would fail. Dave as a researcher, Dave has a label which is an integer. In this case, it would fail also. Emily has a name which is a string and doesn't know any other researchers, but in this case, as we have put here that an asterisk, this star means knows 0 or more researchers. So if she doesn't know any other researchers, okay, this is failing, and why is okay. If this was a label, it would be valid. But notice that this is a schema name, and we put RDFS label. So this is failing because she doesn't have an RDFS label, but this is a different property. And finally, Frank. In the case of Frank, he has a label which is a string, knows other people who are researchers, but has another property which is the email. So in this case, depending probably if I did here a poll to the listeners, if you think that it should validate or not, maybe half of you would say that it should validate, and the other half would say that it shouldn't. Why? Because it is following this structure, but it has another property, like a strange property, which is the email. So what do you think? Should it validate or not? Okay, you are quiet. So it depends. So what we did, would like to say, okay, I don't know if I have a way to make use. Okay, Alex says, I think it should validate. Yes. So what we did in SEX is by default, the shapes are open. And when we say that they are open, it means that we allow extra properties. So if we have a model and you define only the properties that you have here, the other properties that you didn't say anything about those extra properties, we allow them to exist, and we don't care about those existing properties. Okay, so as Alex and Frederick, yes, you are right. In this case, we assume that it will validate. Oops. So it will validate. But maybe in other use cases, maybe someone wants to say, no, but we want to define an entity schema which is closed, and the only properties that we allow are the properties that we mention in this entity schema. Imagine for some reason you want to be very, very restrictive, and you want to say, okay, I only want to have these properties and not a different property. You could express that in SEX if you put here a closed. So if you go later to an entity schema and you find here a closed, if you write here closed, it will mean that it doesn't allow extra properties. And we can even play with this here. Let's see if it works. The link works. So this is a tool that this is called RDF Shape. And for example, you can see that Frank, let's see, where is Frank? Frank is validating, but if you want to say, okay, I don't want it to validate, you can put closed here. And now if you check validate, Frank, now it no longer validates. Okay, so it depends. So the user or the data modeler here can choose if he thinks that it should validate or not. Okay, so this is and again, this is also interesting if we have time later for discussion. If you think that is this an error or not, if we put close and it doesn't validate, it depends. It depends a lot in the use cases. Maybe this is something that, in my opinion, is interesting, that what we have with entity schemas in Wikidata is what I call an ecosystem of entity schemas. Okay, so you have an ecosystem, so anyone can define their own entity schema for their own purposes, and then you can check, okay, for different purposes. If, for example, if you have an application which is where the security is very important, and you don't want to have extra properties because you only want whatever. I mean, I don't know. Maybe the use cases, it depends, but maybe some use cases you want to be very restrictive. So in that case, you put closed, and then it will validate only the properties that you put there. So the validation process in SEX is that you have like 3 inputs. You have the RDF data, the data. In this case, in our case, it would be the Wikidata, is what we have in Wikidata serialized as RDF. Then you have the entity schema, and then we have what we call a shape map. Is an association between the nodes in the RDF data and the shapes that we are defining in the shape expressions or the sex schema. So we say, okay, does Bob conform to person, and does Carol conform to person? And then the validator would start validating and would say, okay, Alice conforms to person, Bob conforms to person, and Carol doesn't conform to person. So this is the idea of the validator. The whole validation has these 3 inputs and 1 output. Notice that the input, this shape map, and the output are more or less the same, also have the same structure. So we can chain different validators. You could have, and that's, I think, is interesting from an implementation perspective, because you could validate one part and continue validating, and go validating other parts. So this is, and now this is the introduction to the SEX, to the language. Let's try to be quick, but as I said before, if you have any question, just ask. But I think it's interesting to have this introduction recorded here and in the slides. Node constraints are constraints about the shape of the nodes. For example, if you want to say, for example, the name is a string, so you could say, okay, I want to say something is a string. So this is the set of values that you allow for this property, or also a date. You could also be more expressive. For example, imagine you have a book and you want to say that the number of pages of books should be greater than 1. So you could have this kind of restrictions where you could say is a constraint of that node, or the value of that node should be bigger or 1 or more than 1. Okay, so you could have this, and you can also have min inclusive, min exclusive, max inclusive, and max inclusive. You have the different possibilities. You could also link to another shape. So, for example, the author is another shape, is a person, and you could later refine person. This is, if you go to some of the entity schemas, you will see that, especially the entity schemas that I write, I tend to write entity schemas what I call a lazy way, where I start by the item that I want to model, and if I want to say, okay, the author is a person, but I am lazy and I don't want to start defining what is a person, I just put this open and close curly braces, which means that I allow anything to be a person. But at least I know that later I could refine. I could say, okay, but persons, for example, in Wikidata should have P31, Q5, for example. Then saying that they are instances of human. I could later say that, but usually at the beginning, I prefer not to be lazy and not to compromise too much. Okay. Then you also have what we call value sets. Value sets are sets of values. For example, the gender, sorry for my pronunciation, should be action, comedy, or non-fiction. Then you could also have regular expressions, and I think this is also very important. For example, in Wikidata, sometimes you have a code, and the code is, I know that you have a lot of codes for different purposes, and the code has to follow a specific regular expression. You could define this in Wikidata. You could be more lazy, also saying that it is an IRI or a dot. Dot means whatever. This is so in this case, the book has a property audio with a dot, which means no constraint on audio. And you could also have like this conditionals where you say the maintainer is a person or an organization, and these logical conditions can be and, or, and not. So you could have different combinations, and this can be quite interesting. For example, one of the entity schemas that I wrote sometime for the lexemes, the Danish lexemes with Finn Arup, had a lot of and, not, and different combinations for lexemes. Okay, this is an example of some data that conforms to that. Another thing that you can express is regular expressions. For example, you could say, okay, sorry, not regular cardinalities. For example, you could say the author of a book must be at least one person, so it has one or more. A question mark means optional, so it should be 0 or 1. Maintainer between 1 and 3, so you would only allow 1, 2, or 3 maintainers. And a star, it means 0 or more. So this is the cardinalities. As you said before, yes.
There is a question in the chat. In the example, you have at person versus at comedy. What's the meaning of the at symbol?
Where is the at person? This one?
Yes, here, where it says maintainer at person.
Yes, so the meaning of at is that the value of maintainer should conform to person. So imagine that you have another shape, which is the person, and you define here other properties. So what you say is that book has a link to maintainer, and the value of that maintainer should conform to the shape of person. So in this case, I didn't put constraints here on person, but if you put other constraints of person, for example, P31 Q5, which is instance of human, then when you are validating a book and it looks that there is a property maintainer, it would go to the value of maintainer. Imagine that maintainer is Lydia, and it would check that Lydia is an instance of human. Is that okay?
Yes, and there's another question. Maintainer might be a person, can then be set to agent class to include human and organization? So I guess, could I make the maintainer either a person or an organization?
Yes, it could be done. I mean, as I said, here you could include, where was the sample with horse? You could, for example, this one. So you could say maintainer is person or organization. So yes.
Thank you.
Yes. And let's continue. As I said, so this adds allow us to have this recursive structure. So for example, you can say the book, the author is a person, and then the person knows other persons, or person works for a company, and the company has employees which are persons. Something that maybe is interesting if you want to play with this is that it's not working. This, sorry, I thought it was going to work, but in the RDF shape you can play with it, and it generates this kind of diagrams. This is inspired by UML, but this kind of UML diagrams can be generated automatically. Now it's not working the link, but just take my word for it. It works. As I already talked about open and closed content models. This is what I said before. You can have open by default, you can also close the content model. And also open and close properties, which is also interesting when you have, imagine that you have a book has a code which is an ISBN, and this is fine. And this means that if you have a code that doesn't follow this regular expression of ISBN, it will fail, which is fine. But imagine that you want to have other values of codes. For example, imagine you have in books, you have the ISBN with 10 digits and also the ISBN with 13 digits. You can express this in this way. So you can say, okay, the code, so you can have properties which are repeated, and you could put a question mark to say that one is optional or the other. So this is a way to say that. And there is also, because maybe if you go to the entity schemas, you will find a lot of them that have this extra. So maybe some people wonder what is the extra means. What extra means is that you have a code which is an ISBN, for example, in this case, an ISBN of 10, but that you also allow extra values of this code. So you are opening the property, saying, okay, if you want to allow the code to have an integer, I would allow a code to have an integer, but so what this means is that you must have a code which is an ISBN 10, but you allow other values of code. Okay, this is the meaning of extra. But if you go to entity schemas, you will see a lot of entity schemas that have an extra, especially we use that a lot for P31. For example, in P31, imagine you want to define the entity schema of a doctor. A doctor is P31, a human, but maybe you want to say, okay, extra P31, because maybe he has other values of P31. It's an instance of whatever. Okay, so that's very common. And also in what we call triple expressions in entity schemas is inspired by regular expressions, and it is quite an expressive language. Some people don't realize that it is quite expressive, and for example, you could express these kind of things. And what this means here is that you have a name which is a string, or a combination of first name, one or more first names followed by last name, but you have to be one of them. So for example, if you look to the sample, Alice, which has a full name, Alice Cooper, is okay. Bob has first name and last name, is okay. Carol has two first names and one last name, and that's okay. But Dave, that has only one first name, so this is like mixing both. It has one first name and a full name. This one would fail. Okay. So this is the samples are using the empty namespace. Yes, sorry for that. I use that to avoid it, because otherwise I would clutter the whole list. But yes, here I'm using the empty namespace just to simplify. So yes, sorry for that if that's something. So you could use X column book or whatever. Yes, but I prefer to simplify the slides. Yes. I already talked about the logical operators. You have ORs, ANDs, NOTs, and different combinations. This can be quite expressive. Something that maybe if you go to entity schemas, and later if I have time, I will point you to some of those entity schemas, is the possibility to import from, I mean, when you create an entity schema, maybe what you want to do is to leverage on an existing entity schema and to add some of your own definitions. So for example, imagine you have the entity schema of human, and then once you have the entity schema of human, you want to define the entity schema of a doctor. So what you do is you import the entity schema of human, and then you specialize with the properties of a doctor. So this is something that can already be done. You have this possibility. So for example, what this means is that an audiobook is a book. And here you have, for example, books have a title, and whatever an audiobook is read by some person, for example. So we are specializing the shape of a book for the audiobooks. So we are importing it in our schema definition. And later I can point you to some entity schema that is using this idiom. And then another thing that we added to the language recently is the inheritance. So you can also have extends, which allows you to reuse existing shapes, but you are adding new content. For example, library book extends book, adding an internal code. So you have the two codes, which are the ISBN, the generic ones, the ISBN 13 and 10, but you add another code, so you are extending the shape of book with another property. Okay, so this is something that we already have in the language. And something that I think is interesting, especially I was looking to the previous session. In the previous session, one of the questions was about annotating properties someone was asking, is it possible to annotate properties of schemas? And it is possible that these annotations are machine processable. For example, you can say the name of a book is a label, which is and you can put the label in English and Spanish or whatever, or other machine readable annotations. And this is, I think, is interesting that you know that it is this possibility. Okay, it's not quite common, but it is possible. I have 10 minutes left, so I will just say, okay, if you are interested, there is this book. So we wrote this book, and the book is available online, so you can go to the book, and you don't need to buy the book to read it. So you can click here. You have the whole, so you have all the examples. Most of the samples I took come from the book, so you can take a look at the book. Here's an example with more features. And as I said, sex and Wikidata. You have in Wikidata, you have this. Maybe one problem is that in Wikidata, or it's not a problem, it's a feature, is that in Wikidata, the properties are not as readable as in natural language. So you have to use P31 or P19 and so on. And this W6 is something that we created, which is instead of defining the data model of RDF, it is possible to define the data model of Wikidata directly, so it can simplify the entity schemas. So, for example, here when you have qualifiers, you have to repeat. For example, P166, you repeat it, and you don't need if you are using W6. And also, for example, you can have a time, which is a data type specific for Wikidata. So tools for entity schemas. The tools for entity schemas. Well, the first one is what you have in Wikidata. What we already have in Wikidata allows you to edit entity schemas and validate entity schemas, but at this moment it doesn't have auto-completion, and the validator is a fork of the sex simple, and sometimes the behavior is not the same as we have in the sex. There is the sex simple tool from in JavaScript. There is another tool that sometimes this is what I use when I want to be sure that the validator is doing the right thing. So probably it's what I could call the reference implementation of sex. This is just a tool. If you don't know it, it's an editor of entity schemas, and it has autocomplete. And this one, if you choose, for example, this has the same behavior as the query service. So, for example, if you go, for example, if you hover with the mouse, it says you the name of the value, and for example, here, if you want, you can edit, and you say WDT, for example, control space, you say instance, and it has autocomplete. So this feature is, I think, if you are used to work with the Wikidata query service, probably you are interested in this editor, because I think it's quite nice. Also, Andra Bachmester, he's quite happy with this plugin of JetBrains. So if you want to use it, I didn't use it, I didn't try it yet, so I cannot say how well it is. I implemented, in our group, we implemented this WikiSape, which is a tool that allows you to see the entity schemas. For example, if you go to entities and you want to find an entity schema about, for example, hospital, you start typing, and it says these are the all entity schemas that have the label hospital, and you can obtain the entity schema here. And this is just, the editor here is Jase, so it has the same as before, so you can play with it. But for all of them, I put good things and bad things. This supports entity schemas and is an online tool, but it's not actively maintained, this WikiSape. We did it maybe 2-3 years ago, and we are not maintaining it. Also, it doesn't have an integrated validator. It's work in progress. Okay. And there's several wiki command line tools. This tool, probably nobody knows about it because I implemented this tool, but it is available here. It's in Scala. but allows you to play with Wikibase in the command line. So you can even validate entities using the command line. You also have the sex validators in the command line. And as I said, now I'm switching from Scala to Rust, and I'm working on this new implementation of sex in Rust. I was supposed to do the exercise of creating an entity schema, or should I jump maybe to the applications?
Yeah, let's jump to that with the few minutes we have remaining.
Okay, and then maybe have some time for discussions. So the slides have I put here to create an entity schemas. You have here the link. I don't think it's difficult. So it's just a matter of filling the different forms and following these links. But I have some tips. So this is what I was planning to do. If we did this session with more time, was more practical. I think it's important to understand the difference between the data model of the item and the RDF serialization when you want to do that, because what you are describing with sex is the RDF serialization, and this is important to take that into account, especially if you want to model qualifiers. So that's important. My approach to do entity schemas is to select some prototypical data. So you say, if I want to do a schema for hospitals, I would select 2 or 3 hospitals, and I would try to find what is the common structure of hospitals, usually starting from samples. My advice is not to over-constrain. Sometimes it's very easy to just say, okay, you put a lot of constraints and then nothing validates. And usually, if you go to some of the entity schemas, I usually suggest to for example, to put Sparkle queries, sample Sparkle queries on the entity schemas. So that's usually very helpful, especially for the users, because then you can go and see what are the items that the editor or the author of the entity schema wanted to validate. So that's a good practice. We have this tool that also maybe you don't know, but this tool called Sexer allows to extract automatically an entity schema from the Wikidata. So if you say, okay, let me extract from some RDF data, let me extract automatically the entity schema. It works, but of course, these automatic things maybe are not what you want. So probably what I would suggest is that you can, if you are lazy, you can start with Sexer to extract automatically the whole entity schema, but then you need to do another step, which is to clean what has been automatically generated to adapt it to your data model. And also, this is the sample that I said before, that you can see you can import, for example, this entity schema 69 of disease is importing the disease ontology and other things. So I think it's interesting to say that you don't need to start from scratch, and you can leverage on existing entity schemas. And applications. For some applications, in the previous session, they already mentioned some of the applications. I mean, the obvious application is validating data and improving the quality of Wikidata. I think that's the main goal of entity schemas. But and there's this directory of entity schemas. But there are 2 applications that I wanted to mention. This one is what we have been doing in the last year with Sayed Husseini. I think he's also attending this session, and Andra Bachmester, is that we were using entity schemas to extract subsets of Wikidata. And I think it's quite nice. The idea is quite intuitive. So the idea is you have the whole Wikidata, and you want to extract a subset for whatever purpose, because maybe you are a researcher and you want to have all the humans in Wikidata, but you are not worried about other things. You are only worried about humans. So you could define a schema of humans, and with this tool, you can extract the humans from Wikidata. So this is the idea, and you have the sex and WSex, and it works. I mean, there are different tools, and in the paper, there is a link to the different tools. This is an example that we were using. The running example was the GeneWiki project. So they have these data models where they have the medications, proteins, genes, pharmaceutical products. All of them are linked together, we defined an entity schema. This is the entity schema. Let me see if it works. Yes, this is the entity schema. It's not a small one, as you can see. So this is an entity schema, but this is modeling all the genes, diseases, proteins, etc., that we were interested. And with our tool, we generated a subset of Wikidata that follows, that conforms to this entity schema. So this is what we did, and this is the result. We were proud, we were happy because you could say, why are not you using for this Sparkle, the query service? The problem is that Wikidata query service has a timeout. If you try to run a Sparkle query to obtain a subset, with the timeout, it is not possible. But we were able to extract, to obtain all these queries. And the other thing is, just to finish this part, this is a prototype that we did with one of my students, and also Eddie Pludemou has another prototype, is that you can add, so you can generate a user interface form based on entity schemas. So, for example, this is like, it's not quite useful, and the link is not working. I click on the link before because we did it probably 2 years ago, but this is a prototype that is working, and maybe this is a nice idea that maybe you are interested. I mean, the idea is that, for example, if you have an entity schema, you can create automatically a form where people could validate things or could write, could edit the things. Okay, and also, yes, Alex says that also to generate documentation. And now is the time for discussion. So I have some topics for discussion. I don't know how much time we have.
We unfortunately don't have a lot of time, but what we can do is we have a Telegram group specifically for entity schemas on Wikidata, and people can join that. I will try to find a link later and post it in the chat. And also your slides, maybe you can post the link again so that people have it. The other thing, we have this great page here on Wikidata. So if you are looking for help with writing an entity schema, that's the place to go, just like request a query. This is request an entity schema. And of course, tomorrow we have an open editing session for entity schemas, where we can do some more of this editing together. Thank you so much, Jose. This was great, and a really, really useful introduction to how this all works.
Yes, thank you. Sorry for taking so much time for that.
All good. Thank you so much.